Hello everyone! In today's class, we will continue to learn about the properties of equations and inequalities. In the previous class, we learned that size relationships in the real world include equality and inequality relationships. In mathematics, we use equations and inequalities to express them. In the previous class, we also learned that in order to solve inequalities, we need to learn about their properties. What are the properties of inequalities? Let's start today's learning below. First of all, please recall what properties do equations have. Property 1, if A is equal to B, then B is equal to A. Property 2, if A is equal to B and B is equal to C, then A is equal to C. These two properties are inherent in the equality relationship itself and are its own characteristics. Let's continue to recall property 3, if A equals B, then A plus or minus C equals B plus or minus C. Property 4, if A equals B, then AC equals BC. Property 5, if A is equal to B and C is not 0, then A divided by C is equal to B divided by C. These three properties are different from the previous two properties. They are proposed from an operational perspective, that is, adding, subtracting, multiplying, and dividing on both sides of the equation at the same time, and the equality relationship remains unchanged. This means that the equation has the property of maintaining invariance during the operation process. Let's take a look at subtraction in property 3. In fact, it can also be seen as addition, where subtracting C can be seen as adding negative C. Similarly, division in property 5 can be seen as multiplication, where both sides of the equation are multiplied by one part of C. In high school mathematics, the operations of addition, subtraction, multiplication, and division tend to be more general, so we can merge them. The basic operations of mathematics include addition and multiplication, so these properties are the fundamental properties of equations. Okay, can you summarize what essential properties are inherent in the basic properties of equations? In fact, it includes two types. One is the characteristic of the equality relationship itself, and the other is that the equality relationship maintains the same operation. Please think about it. In junior high school, we summarized the properties of some inequalities from special to general methods. Now, how do you plan to study the properties of inequalities? We have reviewed the properties of equations, and we can use analogical methods and underlying ideas to study the properties of inequalities. From what perspective do we study the properties of inequalities? We can also analogize equations and study the properties of inequalities from both their own and operational perspectives. Can you guess and prove the fundamental properties of an inequality based on the inherent characteristics inherent in the basic properties of an analogy equation? In the equation, if A equals B, then B equals A. Is there a similar conclusion in the inequality? Let's first take a look at the property of inequality 1. If A is greater than B, then B is less than A. If B is less than A, then A is greater than B, which means that A being greater than B is equivalent to B being less than A. Everyone, please think about how you can provide proof. Some people may argue that algebraic problems can be explained from a geometric perspective using the number axis. It is very intuitive. The size relationship between two numbers can also be clearly reflected from the number line. As a mathematician, we should rigorously prove from the perspective of logical reasoning. So far, what we can use is the basic fact of the size relationship between two real numbers, which we can use to prove property 1. Please think about the similarities and differences between this property and the property of an equation. Their similarity lies in their own characteristics, while their difference lies in the directional nature of the inequality sign. When changing the position of the real number, the direction of the inequality sign needs to be adjusted. Can you still obtain other properties of inequalities now? Okay, let's take a look at property 2 of the inequality. If A is greater than B and B is greater than C, then A is greater than C. To prove this conclusion, we only need to prove that A minus C is greater than 0. We know that A is greater than B, so A minus B is greater than 0, and similarly, B minus C is also greater than 0. A minus C can be expressed as the sum of A minus B and B minus C. We only need to prove that A minus B plus B minus C is greater than 0. Why is this greater than 0? In fact, both A minus B and B minus C are positive numbers, and adding a positive number to a positive number is still a positive number. In this way, we can prove that A minus C is greater than 0. Okay, let's take a look at the specific proof method. There are two basic facts about the size relationship of real numbers. We can obtain that a is greater than b, and a minus b is greater than 0. Similarly, if b minus c is greater than 0, we will obtain that the sum of these two is greater than 0. Therefore, we can obtain that a minus c is greater than 0, that is, a is greater than c. Please think about it. Can you guess and prove the basic properties of the inequality based on the idea of invariance in the operations contained in the analogy equation? Let's take a look at property 3. If a is greater than b, then a plus c is greater than b plus c. To prove this conclusion, we only need to prove that a plus c minus b plus c is greater than 0, that is, the size relationship between a minus b and 0. Let's take a look at the specific proof. If a is greater than b, we obtain that a minus b is greater than 0. In this case, a plus c minus b plus c is greater than 0, which means that a plus c is greater than b plus c. Okay, can everyone describe this property in written language? The description in written language is as follows. Adding the same real number to both sides of an inequality results in the same direction as the original inequality. We can see that the description in written language is actually very straightforward, making it easy for us to understand the essence of this property, which is that inequalities have sign preservation in addition operations. The size relationship between two real numbers can also be vividly represented on the number line. Can you explain this property from a geometric perspective? Firstly, let's draw a number line where the positions of points A and B represent the magnitude of the two real numbers A and B. If C is positive, it means that 2 points move the same distance along the positive direction of the number axis. By obtaining points A1 and B1, we can also see from the graph that the relative positional relationship between A and B, as well as A1 and B1, has not changed. If C is negative, it means that points A and B move the same distance in the negative direction of the number axis, resulting in points A1 and B1. We can also see from the figure that the relative positions of A and B, as well as A1 and B1, have not changed. If C is 0, it means that points A and B have not moved, and their size relationship remains unchanged. The geometric language allows us to understand this property very intuitively, and also encourages us to use a geometric perspective to understand algebraic conclusions, allowing us to have a deeper understanding of new knowledge. Can you draw any conclusions from property 3? From property 3, we can know that if a plus b is greater than c, we add negative b at both ends of the inequality, so that we can obtain a greater than c minus b. This conclusion actually tells us that if we change the sign of any term in the inequality, we can change it to the other side of the inequality sign. Let's keep thinking. Can we get any other conclusions about the inequality? Let's take a look at property 4. If a is greater than b and c is greater than 0, there is ac greater than bc. If c is less than 0, there is ac less than bc. Why is there a classification discussion when both sides of an inequality are multiplied by the same number? Let's take a look at the conclusion of this property, which is actually comparing the size relationship between AC and BC. To compare the size relationship between these two, we only need to determine the difference between AC and BC, that is, the relationship between a minus b multiplied by c and 0. From what is known, we can know that a minus b is greater than 0. When a minus b is multiplied by c, its sign is determined by the sign of c. Therefore, we need to conduct a classification discussion. How can we describe this property in written language? His description is as follows. If both sides of an inequality are multiplied by a positive number, the resulting inequality is in the same direction as the original inequality. If the same negative number is multiplied together, the resulting inequality is reversed from the original inequality. The description of textual language still reflects its very straightforward characteristics and helps us understand this property. This property actually tells us that the multiplication operation of inequalities has its own characteristics. We just learned about properties 1 to 4, which include addition and multiplication. These four properties are fundamental to inequalities. What are the similarities and differences between inequalities and the basic properties of equations? Their commonality is that they all have two characteristics, self and operation. Their difference lies in the directional nature of inequality, reflexivity in inequality, and the need to adjust the direction of inequality when multiplying negative numbers at both ends of the inequality. Okay, let's think about it again. Can you also speculate and prove other properties of inequalities by utilizing their fundamental properties? Let's recall property 3 from earlier. If a is greater than b, then a plus c is greater than b plus c. This property adds the same real number to both ends of the inequality. What kind of conclusion would arise if different real numbers were added at both ends of an inequality? Let's take a look at property 5. If A is greater than B and C is greater than D, then there is a conclusion that A plus C is greater than B plus D. How many proof methods can you find for this conclusion? First, let's take a look at the first approach. To prove that A plus C is greater than B plus D, simply prove that A plus C minus B plus D is greater than 0. Based on the basic fact that A minus B is greater than 0, C minus B is greater than 0, and whether a positive number is added to a positive number or not, we can solve this problem. This is based on the fundamental fact of the size relationship between two real numbers for proof. Can you use the properties 1 to 4 we just learned to prove this conclusion? Let's take a look at solution 2. According to property 3, if A is greater than B, then A plus C is greater than B plus C. Similarly, B plus C is greater than B plus D. Based on the transitivity of property 2, we can conclude that A plus C is greater than B plus D. Let's continue to think about property 4 where the same real number is multiplied at both ends of the inequality. What conclusions would arise if we multiply by different real numbers? We speculate that if A is greater than B and C is greater than D, then there will be a C greater than BD. Let's take a look at the basic properties of inequalities, where multiplication does not have sign preservation, but we also know that multiplication of two positive numbers has sign preservation. Therefore, can you revise the above conclusion? Okay, after our correction, we obtain property 6. If A is greater than B and greater than 0, C is greater than D and greater than 0, then AC is greater than BD. In this property, if we make it special, such as A and C, B and D. Do you have any new conclusions at this point? Okay, we can conclude that if A is greater than B and greater than 0, there will be a situation where A is greater than B. Similarly, we can also have a cube being greater than B cube and a 4 power being greater than B 4 power. Therefore, we can draw the following conclusion, which is property 7. If A is greater than B and greater than 0, then the nth power of A is greater than the nth power of B. In this case, n is a positive integer greater than or equal to 2. So far, we have learned the properties of 7 inequalities and the basic facts of the two real number size relationships we learned in the previous class, which are the basis for us to solve inequality problems. Next, we will use them to solve simple inequality problems. Please take a look at this example. Given that A is greater than B and greater than 0, and C is less than 0, find out that the ratio of A to C is greater than the ratio of B to C. Let's analyze that in order to prove the validity of this conclusion, and since we know that C is less than 0, we can first prove that A is less than B by 1. By using the fact that A is greater than B and greater than 0, as well as property 4, we can prove the validity of the conclusion. Okay, let's take a look at the specific proof method. Because A is greater than B and greater than 0, multiplying A by B is also greater than 0, so its reciprocal is also greater than 0. By multiplying both ends of this inequality by 1ab, we can obtain that 1b is greater than 1a, and because C is less than 0, we can obtain that the C in A is greater than the C in B. Okay, let's summarize the content learned in this class. In this lesson, we focused on studying the basic properties of inequalities and the common properties of inequalities. Can you recall how we studied the properties of inequalities? Firstly, we have sorted out the basic properties of equations and the ideas and methods they contain. Then, we hypothesize and prove the basic properties of inequalities from the perspectives of their own properties and operations. Next, we infer some common properties of inequalities based on their fundamental properties.